to x. It is 4 only. It is 4. Why? Because 4 into x1. Differentiating the third equation with respect to x again. So this is del square f upon del x del y. This is to be different with respect to x. So x is 1. 1 into 4 is 4. Okay. This is your question number. Let me take. This is the fourth one. This is the fifth one. Now, let us find out the points, double point. For double point, for finding the double point, what we do, we equate, we put del f upon del x equal to 0 and del f upon del y equal to 0. So this equation equal to 0, this equal to 0. First equation is 0. This is twice into twice by plus x plus 1 plus 12 into 1 minus x whole square equal to 0. Okay, this equation is 0. Second is this is 4 into twice by plus x plus 1 equal to 0. Now if this value, if I put here 0, but twice by plus x minus plus 1 equal to 0, if I substitute in the first equation, let me take this is sixth equation and this is the seventh one. Solving these two equations, what do we get? This whole value equal to 0, second equation. From second equation, if I put this whole 0, 1 minus x square equal to 0, or x equal to x square equal to, sorry, this is 1 minus x only. 1 minus x whole square, I'm sorry. This is 1 minus x whole square. Not 1 minus x square, but 1 minus x whole square within bracket equal to 0. So if I substitute this value in the first, this sixth one from seventh, this 0, but this value is 0. So 1 minus x equal to 0. 1 minus x equal to 0 or x equal to 1. Value of x is calculated. If I substitute x equal to 1 in the second equation, seventh one, 1 plus 1, 2, twice by plus twice by equal to y equal to minus 1 again. So twice by plus 2 equal to 0. Y equal to minus 1. So again point is 1 minus 1. Okay. So 1 minus 1 is the point required. Double point. So at this double point, let me check whether the curve satisfied or not. It is 1 and minus 1. X is 1 and y is minus 1. Solving these two equations, we have calculated x equal to 1 and y equal to 2. So there is only one point possible. Now this point is satisfying the given equation or not. Let me check it. Okay, question number third is twice y is minus 2, y is minus 1. It is minus 2 plus 1 plus 1 plus 2, because this is plus 1 plus 1 plus 1, 2, this is minus 2, 0. Left hand side is 0. 0 equal to, in this case, x equal to 1, so this is also 0. Okay, so 0 equal to 0. Satisfied. This point 1 minus 1 is a double point. Possible because it is satisfying the given equation. So 1 minus 1 is the double point, possible double point. Now at this point, is it a cusp, is it a node, or is it a conjugate point? Let me check that. For that, we have to find out the values of this del square f del x square. Here it is 1 minus 1 0, so del square f upon del x square. Del square f upon del x square at the point 1 minus 1 equal to, because here x is 1, 1 minus 1 0, this term is 0, or 2, it is 2 only. Del square f upon del x square is 2. What about del square f upon del y square? I'm sorry, what is del square of f upon del y square? This is only 8. 4 to 8, I'm sorry, this I have not calculated. Del square f upon del y square is equal to 4 to the 8 only, because y is differentiated. Y is 1, but it is twice into this, so it is 8 only. Del square f upon del y square is 8. 8 to the 16. What about del square f upon del y? It is also 16. Wonderful. It is 4. Del square f upon del y square is equal to 4 here. Why it is 4? Yeah. From this one, we have taken this from this point. Sorry, del square, this one. This is 4 only, because x was differentiated. 1 into, okay, 4. Del square f upon del x del y is equal to 4. So this square is 16. This is also 16. Very good. This is del square f upon del square. This implies that del x del y whole square equal to 16, but 4 square. This is 4 square here, 16. This is 8 to the 16. So we see here that there are coincident tangents. So tangents are coincident. Cusp will be there. So that cusp, so at point 1 and minus 1, del square f upon del x del y whole square is equal to del square f upon del x square into del square f upon del y square. This is proved. Why? Because this is 4 square. This is equal to 2 into 8. 2 into 8, that means 16. This is also 16. So 16 equal to 16. That means tangents are coincident. So coincident tangents are there. It means cusp will be there. So cusp will lie. Now let me check whether that cusp is of what varieties. First specific, second specific, of what kind. So at 1 and minus 1, the double point is a cusp. The double point is a cusp. What do we do? Let us shift the origin to this point. So shifting the origin to the point 1 and minus 1. We get, what do we get here? So from this equation, this one, 2 into y is y minus 1. This is y minus 1 into 2. Y 2 into y minus 1 plus x is x plus 1. This is plus 1 whole square is equal to 4 into 1 minus x is x plus 1. That means minus x minus 1. This is the whole cube. From this we get to 1 minus cancel out, minus 4 x cube. So minus x whole cube is minus x cube, minus 4x cube. On the left hand side we get, let me further solve it. This is twice y minus 2, sorry, 2y minus 2 plus x plus 2, 2 cancel out, whole square equal to minus 4x cube. So it is twice y plus x whole square is equal to minus 4x cube. Again, if I substitute twice y plus x equal to p, let's consider here twice y plus x, okay, is equal to p, small p. Here y is equal to or x equal to whatever we can write here. So x equal to, okay, now in this case there is a cusp, but quality of cusp we have to find out. So if I solve it in another way, if I equate the smallest term of this equation with twice y plus x equal to 0, or this equation is equal to 0, or twice y equal to minus x. Okay, so this is a different kind of, because x value y equal to, if I just take this minus x upon 2, for positive value of x, y is negative. Okay, and for negative value of x, y is positive. Different terms are coming. It means the cusp will be of first species. Why? Because for y, x positive, smaller value positive, but it is negative, so y will be negative. And no need of putting the y here, p here. And for x negative, y will be positive. What does it mean? It means different values are coming out. Okay, so y is different. Here y is equal to minus x upon 2 for positive smaller values. Positive smaller values of x. Smaller values of x. Smaller values of x. Y will be negative. Only single negative value. There is a cusp of second species. Why? There will be a cusp in the same direction. Y is x positive, y is negative. Okay, x positive, y negative means in the fourth quadrant we will have the curve, and for x negative, y is positive. So it means there is a second quadrant. Okay, in the second quadrant the point will be there. It is a cusp of second species. Okay, of second species here. So cusp will be of second species, because there will be a cusp in the third quadrant, fourth quadrant. There is a double cusp of second species. We can say double cusp of first species. So there will be a y will be negative, and for negative value of x, y will be positive. And let me add that value also. And for negative values of and smaller values of y of x, y will be positive. Y will be positive. So different values are coming out. That means cusp will be of first species. Second species of first kind of first species. Double cusp of first species. There will be the cusp will be of first species. Double cusp of first species. The cusp will be of first species of double cusp type. Double cusp of first species, you may say. Double cusp of first species. So there are two different cusp in different quadrants. Okay, that is how we have to take. Question number 3 we have done. Or we could replace 2y plus x equal to p and substitute that value in the given equation. Then we will find out values of p also for different values of x and y. That can also be done. So this is question number 8 here, 9th here, 10th. Okay, and then other points are there. Let me take question number 4 here. Question number 4 is this. Examine the curve x cube. Examine the curve x cube. This one plus twice x cube. Question number 4 here. Let me take the curve. Given curve. The given curve is fxy is equal to, this is x cube plus twice x square plus 2xy minus y square plus 5x minus 2y equal to 0. Okay, then this question, no problem. Examine the curve dish for singular points and show that it is a cusp of first kind. We have to show that it is a cusp of first kind, and show that it is a cusp of first kind. Let me take the what kind of this singular point, double points are there. So this curve is there. Differentiating solution, let me find out. Differentiating it with respect to x, and by differentiating it partially with respect to x and y respectively, we get, what do we get here? So it will be del f upon del x is equal to, this is 3x squared plus 4x, this is plus 2y only plus 5 here, and the y terms are 0, these two are 0. Okay, then again del square f upon, let me take del x square, that also let me calculate. This is again differentiate with respect to x, it is 6x plus 4 only. Okay, then del f upon del y also, let me calculate del f upon del y. It will be this equation 0, 0, this is twice x, y is 1, minus twice y, minus 2, this one, with respect to y. Again differentiating it with respect to y, so this is del square f upon del y square is equal to, this is y minus 2 only. So y is differentiated, x is 0. And del square f upon del x del y, what is this? So this is to be different with respect to x here, it is 2. These two are zeros. For this to be differentiated with respect to x, del f upon del y is to be differentiated with respect to x. So this term only will be differentiated. This is 2 only, x is 1, differentiation of x is 1. Okay, so these two values, now 3 values we have obtained. This one is this 6x plus 4. Okay, now let me solve for double points. For double points, for finding the double points, equating del f del y and del x to 0. So we get this is 0. This implies that 3x square plus 4x plus 2y plus 5 equal to 0. And the second one, this one, twice x minus twice y minus 2 equal to 0. Okay. So what do we get? If I substitute these two values, twice x plus twice y, alright, if I add them, then this equation will be there. So if I add them, twice y cancel out. Adding this fourth and fifth, let me take this as any number. Adding these two equations, adding on addition of these two equations, adding these two equations, we get this minus twice y plus 2y cancel out, and this will be 3x squared, 4x plus 2x is 6x. Okay, 2 by cancel out, 5 minus 2 is plus 3 equal to 0. So we get here x squared plus twice x plus 1 equal to 0. It is nothing but x plus 1 whole square equal to 0. This is x plus 1 whole square equal to 0. X equal to minus 1 from this. X equal to minus 1 2 times. Minus 1. Okay. Only minus 1 is there. So x equal to minus 1 point. So x equal to minus 1, if I substitute in the second equation, we get y equal to how much? x equal to minus 1 if I substitute in the second equation. Here it is x minus y equal to 1 from this equation, and x is 1. We have just calculated, sorry, minus 1. X was minus 1 here. Minus 1 and that is plus 1, so y equal to minus 2. Why? Because x is minus 1. Take minus 1 to that side, it will be plus 2. So minus y equal to plus 2 or y equal to minus 2. So point is minus 1 and plus 2. So here double point is minus 1 and plus 2. Okay, because x was minus 1. X 1 plus x whole square or x plus 1 whole square equal to 0 or x equal to minus 1. X was minus 1 and y is minus 2. Sorry. Y is minus 2. Now, at this point, let me check whether this satisfies the given equation or not. Whether this equation is satisfying the given equation or not. Which one is this fourth one? Okay, so x equal to minus 1. This is minus 1 here. Let me write first is minus 1 because minus 1 whole square is minus 1. This is plus 2 only. X is minus 1 whole square is plus 1. This is minus 2. I'm sorry, this is y is plus 2. So y is minus 2. And x is minus 1. Y is both are negative, sorry. Both are negative here, y is equal to minus 2. And x is minus 1. Both are negative ones. So we have to substitute y equal to minus 2, x equal to plus 1, so that is plus 2 to the 4. This is plus 4 here. This term is plus 4. Well, minus 2 into minus 1, that means plus 2 into 2 to 4. This is plus 2 minus 1. This is minus 2 whole square, 4 minus 4. This is minus 1 into 5 minus 5. Minus 1 into 5. And this is minus 2 into minus 2 plus 4. What do we get here? Let us check. Minus 4 plus 4 cancel out. 2 plus 4, 6. Minus 5 and minus 1 is 6. So minus 6 plus 6, 0 is satisfied. The equation is satisfied. That means minus 1 and minus 2. Minus 1 and minus 2 is the double point here. Is the double point. Now at this double point, put the value of these two equations. Let me check that. Now del square f1 del y square is minus 2. This is del square f1 del x square. So x is minus 1. Minus 6 plus 4 minus 2. So this is, let me write here. So the values of del square f1 del x square at the point minus 1 minus 2 is equal to this. 6 into minus 1 is minus 6 plus 4 equal to minus 2. This is minus 2 here. Del square f1 del y square is minus 2 already. And this is plus 2 here. Del square f1 del x del y is equal to plus 2. 2 square is 4. Multiplying these two is also 4. This one and this one. So equal, that means coincident tangents are there. So there is a cusp here. So cusp will be of first kind or second kind, that I have to check here. Because these two values are equal. We have to examine singular points and show that it is a cusp of first kind. If there is a cusp, this is possible. Where tangents are as del square f upon del x del y whole square is equal to del square f upon del x square into del square f upon del y square. 4 is equal to 4. That means coincident tangents are there. Tangents are coincident. The cusp here. Cusp was already there because we have proved that this is equal to this. So it's the cusp. Sorry, cusp will be there. Tangents are coincident. Coincident tangents are there. Tangents are there, so it will be a cusp. There will be a cusp. Are there, so there will be a cusp. Double point will be a cusp here. So there will be a cusp here. What kind of cusp is this? That let me check. Shifting the point here to the origin to the double point, shifting the origin to the double point, -1 and -2, sorry, this -1 and -2, which we have just calculated. It's a double point here. Shifting the origin. So what we do, we put here in place of x as x -1, it will be x -1 whole cube, okay, plus 2 into x -1 whole square plus 2 into x -1 into y -2. This is minus y -2 whole square. Or if I equate from the given equation, we just simply do this. What we do, we equate the square terms. This is twice x square minus y square equal to 0, and y equal to plus minus 2x square. That is also possible because here we are having, we are shifting the origin to double point, so we can shift shifting the origin to double point. This that is also possible, but here we have given this y square and this x square. The square terms are there. If I equate them, so y equal to plus minus x here, and the root 2 into x. So for positive values of x, y will be plus minus 2 values. There is a cusp of first species. And there also we could do. So equating the square terms. Now equating, how do we find out the tangents? Because here tangents we have to find out. Coincident tangents are there, but what the equation of tangents? So equating the square terms, which are lowest degree terms, the square terms of the given equation of the given curve to 0. That could also be done. That means twice x square minus y square equal to 0, or y square is equal to 2x square positive, or y equal to plus minus root 2 into x. Now for positive value of x, small positive value of x, y will be plus minus 2, root 2. That means there will be a cusp of the first species. Why first species? Because there are two values of y, positive and negative. So in the first and second quadrant it may be, so the cusp will be of first variety, first species. So let me write here, for positive values, positive and smaller values, positive and smaller values, smaller values of x, y will be positive and negative. Y value will be positive and negative both, or values of y will be positive and negative both. It means the cusp will be of first kind. First species of cusp will be there. The cusp, so the cusp will be of first species. Will be of first species. Okay, in the one side of the y-axis. So this is question number. Which one? Fourth one we have done. We have proved here and proved. It says for singular points and show that it is a cusp of first kind. It is a cusp of first kind here. Okay, so this is question number 4 here. We have done. Now let's talk about fifth question. Now question number 5th. Let us talk about the 13th question, last one, and question number 5th. Fifth question. There are 13 questions total. Question number 5th here. Let me talk about where the curve given to us is fxy. The curve given is x4 minus twice a y cube minus 3a square y square minus 2a square x square plus a4 equal to 0. Now find the coordinates of the double points on the curve dish. Coordinates of the double point we have to find out. For the coordinates of double points, let me check them. This is only coordinates we have to find out. Okay. So this we have calculated. So solution. We have to solve this equation. So differentiating it partially with respect to x and y respectively. So we get, what do we get here? This is del f del x equal to, this is 4x cubed, first one. This is 0, this term is 0, this is there, this is minus 4a square x, and this a4 is 0, the first equation. We take this is second equation, this is the first one. And del f del y is equal to this equation y. So y is only this term minus 6a y square. 3 2 is 6 minus 6. This is also there. This is minus 6 again a square y. This is minus 6 a square y. This is 0, this is 0. Okay, these two terms are there. And then del square f upon del x square. Differentiating with respect to x again. This is 12 x square. Second is minus 4a square only. And del square f upon del y square. From this equation, with respect to y, we have to differentiate it. Is minus 12a y. Minus 12ay. This is minus 6 a square only. And what about del square f upon del x del y? This we have to find out only the coordinates of the double point. Let me check that. So this can also be calculated. Del f upon del y, this with respect to x is 0. Here there is no x term. And del f del y, so this is 0 here. Okay, so this is equations. These are the equations here. Now solving these two equations for finding the double points. Finding the double points